PTC Creo has extensive simulation capabilities, enabling designers to easily analyze both parts and assemblies. You can investigate the structural, thermal, and motion behavior of your designs under real-life conditions. To begin your analysis, PTC Creo provides an easy-to-follow process with an intuitive user interface. In this case, loads are quickly applied to a steering assembly, reflecting a range of motion the wheel would experience after hitting an obstacle on the road. Executing the analysis is simple, and while the simulation runs, visual feedback is provided, allowing you to confirm that the loads have been properly applied. Once your simulation is complete, the results are provided through clear, informative graphs and dynamic visuals. This dual feedback provides designers with an immediate understanding of how a mechanism is functioning, including the dynamic loads generated in the assembly. In turn, these loads can now easily be used to perform further analysis on individual components. For example, structural analysis can be used to evaluate the performance of a component against specifications. In this case, using the dynamic loads to analyze the stresses generated in this connecting bracket. Once again, setting up the analysis is intuitive. Simply follow the steps to select material properties from an extensive library, apply the loads to the relevant areas, and finally, apply the boundary conditions. One major advantage of PTC Creo is automatic mesh generation. It requires no interaction from the user to create a high-quality mesh for analysis, saving significant time. Once again, executing the analysis is simple and fast with PTC Creo's powerful embedded solver. In addition to this linear static analysis, you can also conduct nonlinear, buckling, and dynamic simulations. And interrogating your results is easy using contour plots, animations, and graphs. You can also automate the creation of reports for sharing this information. The next step is to act on these results, and optimizing parts is simple with PTC Creo's seamless integration of analysis and modeling. This ability to quickly optimize parts can generate significant value for companies in the product development process, in this case to reduce the weight of the part while staying within specifications. And this process can even be automated to quickly iterate design variants, eliminating what is typically a manual effort. We can then reuse the previous analysis setup to quickly obtain and visualize results. With PTC Creo, you can also conduct thermal simulations. Similar to mechanisms in structural analysis, setup uses the same easy-to-follow process with an intuitive user interface, thus reducing product adoption time and permitting designers to be productive faster. Once again, the analysis is simple and fast, making results quickly available for review. These results, in addition to the mechanical loads, can then easily be applied to the brake disc. This enables you to better understand how thermal expansion will impact the structural integrity of the part. Furthermore, multiple load cases can be analyzed simultaneously, enabling designers to understand the individual or cumulative effect that different boundary conditions will have on a part or assembly. In this case, investigating the level of stress and deflection in the brake disc as a combined effect of mechanical and thermal loads. With PTC Creo's comprehensive simulation capabilities, designers are empowered to easily analyze parts and assemblies. And with seamless integration between analysis and modeling, designs can be quickly optimized to drive immediate value into your product development process.